Well, good morning, everyone. Well, depending on where you are. My name is Tracy Sturz, and I'm the president of PGLA. And I wanted to, again, welcome you to our webinar today on preparing for a 17025 accreditation assessment. I've been with Perry Johnson for, this is my 20th year as the president for PGLA. And prior to that, I also worked for Perry Johnson's certification side. And we wanted to do this webinar today to reach out to not just our US space. We do, if most of you might know that we're on the call today, we do these webinars every month, typically at 1 o'clock Eastern time here in the US. We wanted to reach out to our global customer base. We do accredit laboratories all over the world. We accredit actually in about 30 to 40 different economies at this time. And we felt that it was important for us to do a webinar on a time zone that would be accommodating, again, for our global customer base. I will would like to, we'll be welcoming Gordon Antonello, who is one of our technical assessors, also a consultant in the industry who wanted to help assist us today with this webinar. Gordon actually lives in Europe, in Spain, and he will be presenting later today on 17025 and common nonconformities that laboratories have, and just provide everyone an overview on the 17025 standard and what it takes to become accredited.
Hello, everyone, and welcome.
Thanks, Gordon. Okay, so just a few housekeeping things for our webinar today. This webinar is going to be recorded and it will be available on our website. So if there's anyone in your facility that wasn't able to make it today, this will be available for download. As you probably already noticed that all the attendees are in listen only mode. However, though, we do have some time at the end of this webinar for some questions. We'd like to keep this as interactive as possible with all our attendees. So if you look at your far right, you should have a toolbar a question toolbar. You can start typing questions in. If you're hearing something as we're presenting today and something comes to mind, even if it does get answered later, no big deal. Go ahead and type it in the question bar, and Gordon and I will be answering those towards the end of the call. Also, we're going to do something different today. We're going to do some poll questions. Gordon and I both will have some questions for the audience. So if you can please participate in those, we certainly appreciate it. So overall today, we're going to be educating attendees. I want to talk a little bit about the accreditation process, the expectations of becoming and maintaining accreditation as well. I know that there's some members of Perry Johnson already that have signed up and are on the call, but I don't think it will hurt to hear about the accreditation process, especially those laboratories who have just become accredited. May also want to know what's expected after the accreditation process, or there might be attendees on the phone today as well that are looking at becoming accredited. So I'm going to go over that process. And then Gordon's going to talk again about 17025, some common challenges, and then we will have the opportunity for everyone to ask some questions. Okay, so I'd like to pull up poll question 1. We would like to know who was on the phone today. So what industry are you from? If we can pull up the poll question. We'll have to take a few seconds to answer. Okay, so I did review the poll, and it looks like 75% of our attendees today are laboratories. No assessors are on. 14% are consultants, and 11% is other. Okay, great. Okay, just to give everyone a little history of our company and you know what we're all about. We are headquartered in the United States. We're in Troy, Michigan, which is right outside of Detroit. We also, again, accredit laboratories in various countries. 30 different countries we have accredited certificates out there, but we do have particular offices in Mexico, Japan, Italy, UK, and support in the Middle East. PGLA is an ILAC MRA signatory for testing labs, calibration, inspection, reference material, and for medical. And we have about 1,500 accredited facilities. Just to give everyone a little history about our company, so Perry Johnson is our sole stockholder. Perry started in the industry in the 1980s, really with training and some consulting work back in the day. Later, he then opened a certification body, which is Perry Johnson Registrars. And then our organization came shortly after in '99 on the laboratory accreditation side. With that, in 1999, ILAC really, it existed, but not when we first opened. So with our accreditations, really, it was more of a national approval in the US, where the automotive groups were recognizing certain accreditation bodies for their sector individually. And later, regulators recognized ILAC to be that body to recognize accreditation bodies and then recognize us as being an acceptable accreditation for the 17025. And throughout the years, we've gained the ILAC MRA signatory status for various sectors. We later then opened up offices since 1999, like I previously had stated, in Japan, Mexico, and just recently in the UK. So as I previously stated, PGLA is an ILAC MRA signatory. Just wanted to briefly talk about what ILAC is. ILAC, again, is a recognition organization. Actually, they recognize about I think now over 100 different accreditation bodies across the world. ILAC is intended to be recognized as the international acceptable recognition organization for laboratories and for accreditation bodies, or accreditation bodies to accredit the laboratories, in order for a one-stop accreditation, one-stop testing lab experience. So what I'm trying to say is that laboratories that might get accreditation by Perry Johnson in the US, that their test report should be recognized globally. ILAC participates in various programs, laboratory accreditation, reference material, inspection bodies. They also have programs for medical labs, reference material providers. They also have what's called regional bodies. PGLA belongs to APAC, but they also have other regional bodies around the world to support all those accreditation bodies. Accreditation bodies follow ISO 1711, which is the conformity assessment requirements for accreditation bodies accrediting conformant assessment bodies. So all of the accreditation bodies around the world all have to follow ISO 1711 if they are an ILAC MRA signatory. Okay, so I wanted to talk about the steps to becoming accredited. There are some laboratories that are maybe on the phone that haven't gone through this process yet. And then again, some that just might want a refresher on how the process works. So if the laboratory is interested in becoming accredited, or even if you are an existing laboratory, you might want to expand your scope. So some of the processes are actually repetitive to even expanding your scope of accreditation. But the first thing laboratories need to do is apply for accreditation for a certain scope. So that means we need to know what tests do you want to become accredited for, what calibrations do you want to become accredited for? And we base our time, our quotation provided to you based on the number of tests or calibrations, or if you're an inspection body, inspections. Once you're satisfied with the quotation, you do have to commit to us for their accreditation terms, which is typically through an agreement for services. We do offer, once that's finalized, all laboratories, if they need it, will receive what's called a pending letter. A pending letter of accreditation, really helps satisfy laboratories, customers that want them to be accredited. But all laboratories are offered a pending letter of accreditation to show they're in the process. Once you establish your terms and agreements with Perry Johnson, you then are contacted by our office. We have multiple accreditation support assistants that schedule the assessment. We do line up our accreditation program assistants to each laboratory by alphabet, by grouping. So you are typically contacted by one person. Makes it easier for the customers, and that person also monitors the assessment material and the certificate issuance to you as well. Once your assessment is scheduled, we do schedule about 60 to 90 days in advance. So if you're looking to get accredited in the next 90 days, it's preferable that you apply for accreditation now, so you could get on the schedule with a certain assessor. Once you're scheduled, we will ask you for a list of documentation that we provide to the assessor to review. This helps the assessor become familiar with your laboratory, and also is somewhat of a pre-documentation audit to ensure that you're ready to go. We don't want to go into an initial accreditation assessment if you're not ready. There could be some back and forth going on between you and the assessor, and some planning. But overall, our goal is to ensure everyone can achieve accreditation, but we just want to make sure we do this documentation review to ensure we just don't come out to the assessment too early. When we come out to the on-site assessment, we do review the quality management system activities that are required in the 17025 standard. And we also look at all of your activities in your laboratory, whether you're testing or a calibration, or even if you're an inspection body, we'll be looking at your inspections. So we will look to make sure that you have the right equipment, the staff, we speak to them and interview them. We'll look to see what type of proficiency testing you've performed, your measurement uncertainty, your data. We will review the methods that you want to be accredited for to ensure you're following them. And again, with all that, we will be looking at particular records and pulling records to show evidence of compliance. Once your assessment is done, we do issue a final report, and that final report will have any nonconformities that are detected. You'll be given the final report at the closing meeting. And the assessor will let you know your timelines for closure of the corrective action. Our process is 60 days. And the corrective action process should include your root cause analysis per what's required of you in 17025, and the objective evidence to show that you've implemented your corrective action. And that will go directly over to your assessor, your lead assessor, and they will review and let you know that your corrective action has been approved. Once the lead assessor approves your corrective action, they then turn in their assessment material to our office for a review, and then we send it off to an independent review committee that makes the final decision. So the assessor makes a recommendation, but the final independent review committee actually makes a decision to accept or deny the accreditation. If something would happen where a laboratory would be denied accreditation, it doesn't mean they can't get accredited. It just could mean that the assessor might need to complete additional paperwork, or the laboratory might have to do additional things to resolve the executive committee's decision. Once that's finalized and the decision is to accept the laboratory for accreditation, we then issue a certificate of accreditation for 2 years. Okay, here is just a demonstration of our accreditation cycle. So here you'll see that you go into the accreditation process. Now, 12 months later, we would like to come, or we require actually a surveillance. It's within 12 months from the initial accreditation assessment. Not 12 months from the time you get your certificate, it's 12 months from your initial accreditation assessment. So if you become accredited in January of 2021, your surveillance is going to be due in January 2022. The surveillance is a partial assessment, and we do look at the previous findings to ensure things have been fully implemented and are still moving along. And then we take a look at annual requirements such as internal audits. Have you done a management review? We'll take a look at one test or calibration being performed on your lab to ensure things are still following the requirements of the standard. After the surveillance, we do what's called a reassessment, and that is 12 months from the surveillance. So if your surveillance goes on time in January 22, for example, your reassessment is due in January 2023. Down here at the bottom, I also made a note because we do have laboratories that have already been accredited. And one of the items I wanted to point out is that if, for example, you start out very small and your scope maybe has 2 or 3 line items on it, and you want to keep expanding your scope, that can happen at any time during the surveillance or reassessment, or if you want to have a separate scope expansion in between, we do allow that. Okay, so I'd like to do one more poll question. I'd like to know from the audience today, how many people are actually accredited or not accredited or working on the process? I'll give a few seconds for that. Okay, so we have 70% voted. All right, everyone's still awake, I guess. Okay, so in our audience today, so we have quite a variety here. We have 49% is accredited, 14% is not accredited, and 37% are looking to get accredited in the future. Okay, so this is good. This is I'm glad I was able to go over the process, because some that are getting ready to get accredited in the future, I hope that I was able to somewhat explain the process. And just so you know, any time during the accreditation process, if you have questions, we're really good at helping, trying to explain the process to, all the laboratories, to ensure they know what to expect. Okay, so what I'd like to do now is welcome Gordon Antonello, who again is one of our technical advisors and assessors, who lives in Spain. He has over 40 years of experience working in product R&D, product manufacturing, and product testing. He's a 17025 technical assessor and also NFC forum assessor as well. Gordon's been around for a long time, and really wanted to help with this webinar today, because with his work a lot with doing his auditing and with his consulting work for laboratories, really thought that doing something like this would be of value to the laboratories. So I'm going to go ahead and give the presentation over to Gordon, and I thank you all for your time, and I will be back on later to help answer any questions.
Welcome, everyone. I'm glad you could all make it, and thank you for attending. Yeah, you can just look quickly over the description of my background, but what's more important is that it's included in the presentation that I'm going to be giving you on this webinar. Okay, the first item or area that we're going to be talking about here is understanding what the lab is being assessed to. Okay, poll question number 3 before we actually get into the meat of it. And the question here is, what is your biggest challenge in being or becoming an ISO 17025 accredited laboratory? Okay, thank you for your inputs. And this gives us a pretty good idea of the attendees here. So it looks like it's a roughly an equal share between the quality management system, which is the guiding documents of your quality management policies and procedures in your laboratory or your organization, and also the challenge of proficiency testing, which is focused on testing and looking for homologation or conformity between your lab and labs that test similar or the same equipment. So let's get going. Okay. Okay, knowing and understanding the ISO 175 to 2017 standard. It states the requirements for competence of testing and calibration labs. And there are four main groupings of requirements, but they're not limited to these four, but these are the four main ones. The structural requirements, which is in essence how the laboratory is structured in the management and organizational point of view. And then the resource requirements, which is one of the topics that we'll be covering during my part of the presentation. And resources are basically sources of effort like staffing, the building, the environment that the lab is in, external suppliers, and so on. And also process requirements, the processes that the laboratory is going to be using in conducting its work. And the final one is the management system requirements. But for today in my presentation, like I alluded to, we're just going to focus on the resource and the process requirements. The resource requirements can be looked at in this star diagram, and it's comprised of 5 main areas. It's the personnel, and in other words, the people that are involved in conducting the business and activities of the testing or certification laboratory, and the facilities and environmental conditions. This is the actual facilities of the lab that they have for conducting their business and activities, and also the conditions that those facilities present while the personnel are conducting their work activities. The third topic is the equipment, which is the equipment used in conducting the activities that the lab is involved in. It could be specialized test equipment from a standards development group, or it could be test equipment that comes from a supplier like Agilent or other similar suppliers of equipment, Fluke, whatever they need in order to conduct the testing or calibration activities that the lab is involved in. And the fourth area is metrological traceability. And that's a resource in the sense that this information is used to help the laboratory make determination on how valid and how accurate that their work activity output is. In other words, the measurements or the results of testing and how accurate those results are. And the final component of resources requirements is the externally provided products and services. For example, a lab may be providing an overall testing process for a electronic device. It does all activities and all testing, which perhaps for a single test, where they contract that work out to a service provider that specializes in doing that kind of testing. So there's an agreement, and it has to fall under the control and the same rules as all the test methods that the laboratory has in their own possession and in line with ISO 17025. And the output and the product from those externally provided service providers is included as the services and output of the lab as they present it to their client. And all these interactions and interfaces are covered under the ISO specification. Okay, we're going to go into a bit more detail on the resource requirements. Personnel. And the key factor here to take from this is that everyone that is involved in delivering and providing the output of the activities that the lab is involved in, whether it's maintenance staff, whether it's test engineering, whether it's those project managers that are bringing clients and equipment in, your tracking and tracing equipment, providing uncertainty measurement calculations or validations, they impact the results of the lab activities. And one of the key things here, they must be impartial. No personal opinions are included. Everything is based on the results of the tests that are conducted, and the tests are conducted using methods and procedures that are clearly and well defined and followed. And that the personnel must be competent, that they understand the work that they're doing, not only from a operational level, but from a technical and engineering level. And they conduct the work according to the lab's management system. And the laboratory's management system includes not only the QMS, the quality management system, but also the operating procedures and working instructions, which are more targeted at the personnel that are involved in conducting the actual testing. In this way, the personnel that are conducting the testing, typically test engineers, follow a common, agreed to, and followed procedure so that there's more consistency in the results that are obtained, whether it's one test engineer running the test or another one. They will get very similar and very consistent results. Another factor that a lot of organizations haven't originally taken into consideration are the facilities and the environmental conditions that the testing or work activities are conducted in. They must be suitable for all its activities and do not affect the validity of results. Example, humidity could affect the results that are measured, or the altitude, the atmospheric pressure, the temperature. Many factors come into play that are under the control of the facility's environment that the tests are conducted in. So these have to be well controlled and well understood. And understood in the sense that these factors have an impact on the results of the activities and the testing that is conducted. Another important factor is the equipment. So the lab must have access to equipment that are required to properly perform its activities and conduct the tests or the calibration that they're involved in. And all those tests, equipment that are involved can and do influence the results of the tests. Their calibration, whether it's in or out of calibration, their tolerances, the measurement uncertainty values, etc. Metrological traceability can be defined as the property of a measurement result, whereby that result can be related to a reference. And this is a term that's used throughout the MU and metrological traceability industry, is documented unbroken chain of calibrations. In other words, if you are taking a measurement of a voltage, there's the source of a voltage, whether it's calibrated, what its uncertainty valuations are. Then that's the source. Then it's the equipment that you use to measure that voltage, the voltmeter, whether it's analog or digital, and what its measurement uncertainty or tolerances are, and so on. The calibration, whether the equipment is in or out of calibration. So that each measurement in the chain getting the resulted output of the activity contributes to the final result. And each level has a level of uncertainty. So in the end, you have a combined level of uncertainty for the resulting measurement. And this is all has to be taken into account when reporting that result to your client. And we spoke briefly already about the externally provided products and services. And the labs have to have the same policies and procedures for their own internal services or activities as they have for those labs that provide services and products under contract to them. So they have to follow the common set of procedures. Their test reports and records have to be homologated, in other words, the same and clearly understood, and have the appropriate information. And all these tests and services that affect the testing or calibration activities that the lab is involved in, whereby they provide these results to their client. Okay, poll question number 2. What is your level of measurement uncertainty? Oh. It doesn't appear that this poll got executed properly. So we can ask this poll and ask for the result to be posted after the conference call is done, or the webinar is completed. Okay. Now we can move on to process requirements. This section of the ISO 175 standard is a bit more involved, and it has quite a number of areas that affect the process. And that's right from start to finish. And it starts with the review of requests and tenders or contracts. So the client that wants to bring a product into your laboratory for testing or calibration, there has to be a clearly defined process at how that is done. Also, the selection and verification and validation of the methods that the lab uses in order to conduct its testing or calibration. In some cases where sampling is involved, and I'll talk more about sampling later, the procedure for doing the sampling has to be clearly defined and followed. And also how the lab handles the test and calibration items, from receipt of the items to storage and control of access, and during the testing of that particular item, how they're handled and processed and tracked. And once the testing is done, how are the records, in other words, test reports, and all the information that are included in the test reports, how are they recorded, controlled, and documented? And the next one is the evaluation of the measurement uncertainty. And then what is the process that the lab has in its quality management system in order to ensure that their results of their testing or calibration activities are valid? And how you report the results. You're reporting the results to a client, for example, or internally. Complaints, we all get complaints. And the process and procedure, how to receive complaints, how to address complaints, how they're assigned, how there's follow-up, the corrective actions that are resulting from that if necessary, and how they're closed. Another one is non-conforming work. That's work that is actually happening in the lab, does not conform to their policies and procedures, and how that is controlled and brought back into conformance. And finally, the control of data and information, and how that data and information is managed and kept secure. So the first one is the requests and tenders and contracts. So the lab must have clearly defined policies and procedures for the review of requests, tenders and contracts in order to ensure that the requirements are adequately defined, that they're documented, and they can be clearly understood by those that are going to be conducting and providing the testing or calibration services that the lab is involved in. And also that it has the capability and resources to meet the requirements. In other words, a response back to the client that, yes, we can provide this service for you, and we are assigning, XYZ equipment, and it'll be conducted using these methods. And here's the training records of the personnel that are going to be doing the testing, for example. And how the client is going to be notified of any externally provided products and services, and how that is controlled, and also how the methods that are going to be used in the conduction of the testing or validation and methods. This is basically for the activity that the lab is involved in. They select the appropriate methods to conduct the testing for the specifications and requirements of their clients. So they have to verify and then validate those methods that they do meet, in fact, the requirements of the client. For sampling, I said I would speak about this. For example, if the testing laboratory is sampling seed, so how do you sample from a large bin of seed, let's say 1 liter or 1 quart of grain or seed, that you're going to conduct the testing, the germination success, for example. So you have to define a procedure for taking that 1 liter or 1 quart sample from a large bin of seed. So these things all have to be documented and followed and recorded on how that sample was taken. For example, in electronics, where you have a mobile device that you want to do a testing on, of course, the sampling is done by the supplier, where they say they have a production run, and we pick 1 or 2 units, and then we send that to the testing lab as a representation of a production run, for example. Okay, handling of test and calibration items. It's basically defining how a calibration or test item is received into the laboratory, how it is handled, its protection and storage, and the recording and retention, and then further disposal of those items. In other words, many labs take the device and they give it an asset number, so it's tracked. And usually that asset number, or it could be a contract number, depending on their method that they use. But this has to be documented, it has to be followed, and it has to be recorded for every test or calibration item that comes into the lab, and the records maintained, which is the next item. You must ensure that all the records of all its activities, whether it's the recording and handling of test items, or the conduction of the test and the test reports, and all its activities are properly recorded and retained. Okay, evaluation of measurement uncertainty. Each time that the lab has a value, an analog value, whether it's voltage, current, temperature, humidity, density, it could be any number of things, tensile strength, the lab must identify all the contributors to the final measurement and the uncertainty of that measurement. So every piece of equipment, including the sample that they're testing, they have to record all the variations and uncertainty of those measurements along the chain. And ensuring the validity of the results is basically that they have a procedure that once the test or calibration is done, that the follow-up by other lab staff, if there's someone that reviews it, signs off on it and approves it, and it is properly recorded and the records are retained before it's provided to the client. The reporting of results is basically outlining how the results of a test or calibration procedure is held, is conducted. In other words, for review and to authorize the results before being released, and that the results, they must be unambiguous. They have to be clear and objectively reported. There's no subjective opinions whether I think it's a pass. It has to be pass, and here's the reasons why. And it also have to be in line with the client's requirements. Complaints. Since this is a real world, the labs must have a documented process that is accessible to their clients, both internal and external, to receive, evaluate, and assign and make decisions on any complaints from clients. And this process must be made available to any interested party upon request. In other words, if a client wants to say, I have a complaint or a problem with the test results that you provided me, or any similar complaint, they have to have access to the process, and they have to be able to enter it in their own way, and then it has to be assigned and addressed, and corrective actions taken. As we spoke earlier, non-conforming work is work that the lab conducts, and that if it's outside of its own procedures, there must be a way that it can be brought back into line with the procedures that the lab has defined to conduct its activity. So there has to be a process for identifying and recording and correcting any non-conforming work that the lab conducts. This could be through training or removing ambiguities from the test procedures or the standard operating procedures or the work instructions and so on. And the final step is the control of the data that's produced from the activities that the lab is involved in, and also how the information management system executes that control of that data. He says that the information must allow access to the data and information needed to perform all the activities for the collection, processing, recording, and reporting, and storage and retrieval of any activity that's resulting from the lab. I use the terms standard operating procedures and work instructions, and these are supporting documentations, procedures, and instructions in support of the quality management system. The SOPs are in general step-by-step directions or instructions to help the personnel carry out complex routine operations. And this is to achieve consistency, uniform results or efficiency, and to provide a quality output. So there's consistency in the output that is produced, regardless of the personnel that is appropriately trained and qualified to conduct the tests. They also help to reduce, by intent, any miscommunication, and they're designed to comply with industry regulations where necessary. And then work instructions are in support of the operating procedures, and they precisely describe the correct way to perform specific tests or tasks and in testing or calibration. And this would help to reduce any erroneous results or results that could be in error were not performed in the correct sequence or manner. So if there's a specific sequence that the testing or the steps have to be conducted in, like setting up a unit under test by setting and configuring certain parameters, then executing test 1 and 2 and 3 and 4 in that specific sequence and adjusting parameters as you go, that sequence has to be clearly defined and followed and recorded. Okay, proficiency testing. This is becoming more and more a useful tool in the global test lab or calibration lab ecosystem. And it's being more and more supported by organizations that actually provide that kind of service. It actually helps labs to demonstrate their effectiveness on their internal procedures in relationship to how reproducible their results are, and also how accurate the results are. And they're very effective to ensuring that their quality control and their quality management system, their operating procedures, their test methods, and their work instructions are clear. And they can be done informally between labs or conducted in a cooperation with a third-party organization. And the PGLA organization does provide this service where they help and conduct proficiency testing. And this helps the labs to be more competitive by proving that their policies and procedures, their methods, and their SOPs and work instructions are at a world-class level and can compete directly with labs regardless of where they are. Okay, it can be conducted in one or more labs. Sometimes you can do intra-lab proficiency testings where some labs have multiple sites. They can do it between their own labs, but also labs that are competitors can also use a third-party proficiency testing house to help them conduct proficiency testing. So the lab can actually see how they perform against their competition to help them improve their internal policies and procedures for them to become more competitive. And we have some links here. There's an organization, eptis.org, that can provide you labs on a global basis with proficiency testing in the area and the activities that the labs are involved in. But also PGLA have resources that are available that can provide the similar and same service as eptis does. And their link there is pglabs.com/resources/proficiency-testing. I'll leave that on for a moment so you can actually write that down. Okay, now the topic of measurement uncertainty. And it's true that every measurement is subject to some level of uncertainty, whether you're taking a tape measure and you're measuring the width of a piece of material or a piece of wood or the distance between two objects, there is some uncertainty or doubt about the results of that measurement. And even when precautions are taken, and I will talk more about that later. But right now, the MU, or measurement uncertainty, is relatively new in the history of measurement. Measurement's been around for thousands of years, and in the area of certification testing as well. MU is separate from errors due to tolerances, or the analysis of multiple tolerances, which have been part of the practice of measurement for quite some time. And error is the difference between the measured value and the true value. That's an error. While uncertainty is the statement of a doubt about the measurement result. You know, when I measure the distance between two objects as 5 meters, how sure am I that it is in fact, exactly 5 meters? There is some doubt, but how, by the person conducting the measurement, by the temperature, that it may affect the length of the measuring device, or the diameter or the positioning of the objects that you're measuring between. Now, uncertainties can come from the actual instrument that you're using, like a tape measure, or the items that you're being measured, or how you're actually obtaining the measurement. The environment that the measurement is made in, the temperature, humidity, altitude, and so on. And also the skill level of those that are conducting the measurement. Does not consider operator mistakes where they use the wrong device to take the measurement, or tolerances of the device that is being used to measure, or any of the specifications in that measurement. On this slide, we're going to look at a very simplistic view of what measurement uncertainty is. And MU has developed rules on how to calculate overall estimate of uncertainty from pieces of data relevant to the measurement. And here's a simple example. A stick may say, or have lines on it that say that it is 20 centimeters in length, plus or minus 1 centimeter, at the 95% confidence level. So in short, it's 20 centimeters plus or minus 1 centimeter at the level of confidence 95%. So that's the statement of uncertainty. I think there's a typo. It says 10 and it should be 20. And the statement says that we can be 95% sure or confident that the stick is between 19 and 21 centimeters in length. In fact, the actual process of determining the uncertainty is more complex, but the above example shows in a simple way what measurement uncertainty is. And at the bottom of the slide, that you can obtain more information on measurement uncertainty on the PGLA website. And the link is there. And other references that are available is an organization that talks a lot about measurement uncertainty. It's called isobudgets.com. So I'll give you a moment to write those links down. Another part of measurement uncertainty is the notion of a statement of conformity to a standard or specification, and any decision rules that come out of the measurements that you're taking and the uncertainty involved in those measurements. And this example shows what that means. So conformity can be defined as a statement of compliance or non-compliance to a specification, requirement, or a standard. Whether that standard is for volts or power or length or density, etc. Conformity, on the other hand, can be stated, for example, as a pass or a fail, or in spec or out of spec. And there are 3 common types of conformity statements that are usually made. One, it's compliant, or it's non-compliant, or the results in indeterminate. And the diagram helps to explain that. Now, this just shows you a simplified example where it has an upper limit line on whatever you're measuring, and the leftmost measurement is the green dot. And when you apply the measurement uncertainty, plus and minus, you see that even with the measurement uncertainty, the final result is within the limit, below the upper limit. So it's within limits. So we could say that that is a pass. The next result, the actual measurement is below the upper limit, is within the limits. However, when you apply the measurement uncertainty, you can see that on the positive side, the measurement uncertainty goes outside the upper limit. And this could be defined as the result is indeterminate when the measurement uncertainty is taken into account. The third measurement, the actual measurement falls above or outside the limits. So this is a fail. But if you take the measurement uncertainty into account, you can see that on the negative side of the measurement uncertainty that the reading or the measurement result may fall below that upper limit and in between the limits. So we could also say that that third reading could be indeterminate if you take into account the measurement uncertainty. The fourth reading, obviously, is fully outside the upper limit with and without the measurement uncertainty. So it's a fail. Okay, now decision rules. So it can be derived based on the information that I just showed you on the slide. So the first result could be a pass, and the results plus or minus the expanded uncertainty are all within the limits. The second one could be a pass, and the results are within the limits, but overlap the limits when expanded uncertainty is taken into account. The third result, we say it's a fail, because the results exceed the limits. However, they'll overlap the limits when expanded uncertainty is taken into account. And the fourth one is a fail because both the results and the expanded uncertainty exceed the limits. And I've got asterisks between the two central measurements. In this case, the decision rule that is used states that pass could be stated as indeterminate. So you could decide on your decision rule saying, if the result is within the limits, even though with measurement uncertainty, it exceeds the limits, the decision rule is that it's a pass. That has to be used consistently every time you take that measurement. And the decision rule has to be clearly stated, and it has to meet the client's specifications or requirements. The third reading is a fail. So the decision rule is that if the result exceeds the limits, regardless of the effect of the expanded uncertainty, it's a fail. But it could be, both of those intermediate results could be stated as indeterminate. In other words, we can't determine whether it's a pass or fail. So these are how decision rules are used in order to record the results when a result is on the cusp of being in and outside of the limit or specification. And these things have to be clearly stated by the labs when they report their results. So if a lab wants to implement and use and get a credit to ISO 17025, these are steps for that implementation. Now, I'm sure that most of the labs already have a quality manager and a technical manager. And this is just a high-level view on what the labs need to have in place in order to obtain that accreditation. They have to clearly define policy and statement of what their role and their objectives are and their mission statement. And if you're not already accredited to ISO 175, you may decide to engage a consultant to develop and carry out an implementation plan based on a gap analysis, which is the next step, which looks at your current quality management system and compares it to the requirements of the ISO 17025 standard. And when you have a good understanding of what the gap is between where you are already, where the lab is already, and what the requirements for ISO is, you have an idea of how to develop a strategy and a plan to bring your quality management system in line with the requirements of ISO 17025, which will give you a much higher likelihood of being accredited. Also, as part of this program, you should look at training and or education on the ISO standard, and specifically also including measurement uncertainty, how that affects your activity in the lab. And determining the scope of the tests that you want to be accredited for, to make sure that you have the appropriate test methods for test instructions and the operating procedures and work instructions in place to have consistent results and while executing those test methods. And also another important key factor here is that to be engaged in inter-lab proficiency testing, as was described in that part of the presentation. Okay, I'd like to thank everyone for putting up with some of the technical difficulties. And it's now time for questions and answers. So we would like you to post your questions and address them.
Gordon, this is Tracy. I'm going to take a minute to go through the question log and just clear the questions I've already answered, okay?
Okay.
Okay, Gordon, I think we're ready to go. Would
Okay.
you like me to?
Yes, if you could start, and the ones that, yeah,
I
the ones
can
that
go through
are
the questions, and then if you want to go ahead and answer, if there's things that might pop up for me, then I'll answer. But I think I answered most of the general accreditation questions. But the
okay.
questions we have are there special considerations for a company with one employee? So do you want to go ahead and answer that? How we do have a lot of labs that are accredited, you know, 1 to 2 people in their lab, small facilities. Is there anything
Yes.
that you want to talk about with, with 17025? There has been some additional requirements about internal auditing and answering complaints that might find one person lab might find it kind of challenging how they handle that process. Any feedback on that with the standard of how someone could accomplish that requirement?
Yes, that's actually a really good question, especially when it comes to impartiality and confidentiality. If it's a single person lab, they have to have policies and procedures in place, and they have to document those where that person or individual, when he's conducting certain parts of the activity, that he does not allow one activity to influence negatively another activity. So that person would have to be able to change and wear hats quite often, but that person will have to, execute or exercise a high degree of objectivity when he's performing the various roles. So we don't have anything specific against just a single person lab. And as a matter of fact, we don't. It's just that they have to very, very clearly define policies and procedures to ensure that there's impartiality between the various roles that individual is performing at a certain time.
Okay, and I'll add to that a little bit too. Like I said earlier, the 17025 2005 standard from the 2000 going to 2017 has that particular requirement where laboratories aren't able to answer their own complaints where it's directly towards their area. So when you have the one person laboratories, it makes it a little difficult to be able to accomplish that requirement. And one way we've seen some laboratories do that is you might have you know, another laboratory in a way maybe down the road that's also accredited, you can utilize their service to maybe help ensure that, you know, you've cleared something okay, as long as it's not a competitive issue. Also, you know, external providers that are out there are consultants out there in the industry that might be able to help review certain things, like, you know, if you have a complaint, have you cleared it okay? Because how are you supposed to separate yourself from if you're a one-person lab? Same thing with internal audits, that as well, you know, that if you have a one-person lab back with the old standard, you were able to do your own internal auditing, where now it might be a little bit more restrictive. So the use of external providers, is a note in the standard about that being appropriate or okay to do. Okay, so the next question is, do you have a list of consultants that can help with the implementation plan? I can go ahead and answer that. We do, if you contact our office, we do have consultants that are also maybe even our assessors, like Gordon, that could help laboratories implement to the 17025 standard. Gordon as well does some consulting activities, which he's free to do. You know, obviously not assess his own labs, he consults, but you know, we do have people available. If you contact our office, we can help refer you a list of consultants. Okay, the next question was, does PGLA provide technical advice on methodology? For example, appropriate calibration, verification, and substitutions, reference method chemicals for methods that are promulgated in US CFR. So with that, as far as technical, we do offer technical advice with all of our laboratories. We just can't consult as an accreditation body. But if there's things that laboratories need to talk to us about in regard to how they're doing something, whether it meets the 17025 standard, we're more than happy to answer those questions. If there's things that are a little bit more detailed about how the laboratory is going to be doing it, or if they need more advice, that would be more in the consulting area. I don't know, Gordon, do you have anything to add about that question?
Yeah, all I can add is to what you've already said. There are assessors and consultants within PGLA that can help the laboratories help with this process and define it with them, so it meets the requirements and of their clients.
Right, and then, you know, when we're looking at this question here too, you know, appropriate calibration, verification, and substitutions of reference method chemicals for methods. So, you know, if there's something that you're doing differently that's, you know, a modified method, or, you know, again, you go back to the 17025 standard and ensure that whatever you're doing is appropriate, things are traceable. You know, if you're using a different method outside of a standardized method, you know, that's where the 17025 standard or method validation comes into play. So if there are things that you are doing, you know, out of the ordinary, and you modify a method, or you're using a material that's not certified reference materials, or you're creating your own materials, again, it all goes back to the 17025 standard. But if you need to run it by us on, you know, how you're going to be doing something, or if there's a question whether or not that something would be okay, we're more than happy to answer that. Next question is 17025 makes reference to customer requirements / communication. How would this be implemented in a lab who carries out activities for business requirements? Okay, should the laboratory treat the wider business as an internal customer? Sorry, I forgot to read the rest of the question. Would you like me to repeat?
I'm not quite exactly clear on this, Tracy. What what he's asking, but is this business internal to the organization? Is this part of a lab? Or is this lab part of a larger organization? That would help answer this question. If it's an external customer or client, it's not an internal client, a customer in any case. They have to treat all their customers and clients as a third party. In other words, the third party or the business that they are part of submits a request or contract, and it's controlled and taken in to the laboratory as if it was an external client, and the testing is conducted in a way that it ensure impartiality, and then the results are reported through proper procedures and test reports. So the lab should treat the wider business as an external customer, although it's internal. I hope that answers the question.
Okay, thanks, Gordon. Next question is, please elaborate about test method verification and validation procedures and parameters. What is involved in accomplishing this?
Okay. Okay. Yes. Let's say, for example, I'll give you just a very simplistic example. Let's say one of the test methods you choose is how you measure the voltage of a device that is supposed to produce a certain voltage within certain limits. So you have a method to measure that. So you define it. You take the device, you place it in for example, in a temperature-controlled, humidity-controlled environment. Let's say the temperature has to be 20 degrees plus or minus 2 degrees Celsius. And the humidity has to be 40% plus or minus 5% relative humidity. So from 35 to 45% relative humidity. And that's part of the process, so verify it. So then you have to say the next step to validate it or verify it is that the next step of the procedure is that I take a calibrated voltage measurement device, like a meter, and you take a measurement of the voltage. And you have to take into account the uncertainty that could be introduced by the probe touching the contacts, and because you have different metals or materials, and that has a effect of producing although minor or minute current because of the metals are different. So you have to ensure that that is minimized, and then you verify that the voltage that you read is within the specified limits. And to validate it, you have to actually conduct the test a number of times, and you see the variation between each of the measurements. And you may see that humidity has an impact. So then you have to specify a tighter constraint on the humidity, or let's say that the temperature has an impact on the measured results, then you have to tighten up the requirements on the temperature, for example, and to repeat it a number of times, and you start getting consistent results that are within the requirements of your client or the services you're trying to provide. Then you've gone through a verification and validation procedure. And the parameters will be voltage, the length of the leads that you're using, the model and the calibration of the meter that you're using to measure the voltage, and so on. And all that has to be documented. So that gives you a very simplistic view of how you verify and validate the test procedure or test method.
Okay, thank you, Gordon.
Okay.
One more question to pop up. Now I need for PT about the authenticity of medicinal plant materials by microscopic method. Please share with me how to do a PT about this method. So in a microscopic method, this might be something more that would be done probably internally at the facility, but do you have any input on that?
Okay, says, please share, you have to do PT about my comment. That, I would suggest that you contact a third party or even PGLA. They have contacts that would conduct the same type of measurements as you do, which in this case is medicinal plant materials. And they would look at your test methods and the services and what you're trying and materials that you're trying to test, and they would put you in contact with they would arrange to run proficiency testing with controlled samples. So you would that lab would conduct their testing with the controlled sample, provide the results to that third party. The third party would use similar or the same batch or the same sample group of plant material, and have that another lab conduct the same tests, and then run a comparison between the two and provide the results between the labs to ensure that there's impartiality and there's no names identified, and to do a comparison of the results. And this is how you would show and do proficiency testing using those methods. So the third party would take into account the method that's used, the equipment that's used, the environment that the testing is conducted in, and so on, and the proficiency and capability of the people and personnel that are conducting the tests.
Okay, let me just take a look. Yeah, we had a question, it's quite lengthy, but the question is, if there are requirements under the US CFR for a particular method, laboratory may use substitutions for that method. Under the ISO standard, will we get credit if it proves it's reliable? So I think that part of the, Gordon, you can add to this, that part of the 17025 requirement though is to, you always are going to want to use any national standardized method that's available and might be required of you of the laboratory per certain legal obligations or, federal requirements. But if a laboratory does any type of modified method, one, they really can't claim that they follow, depending on how much they modify any type of method, on their scope of accreditation on the annex from the back, they wouldn't be able to claim that particular method, would have to say modified. And then we would go back to the 17025 standard again for how they validate that method. And they have to prove that the method that they are doing is fit for use for what they're trying to accomplish. So, in most cases, laboratories should use the standardized methods that are available because it removes that whole validation process, which is not easy for laboratories to do. But if they choose to modify on their scope of accreditation, we don't put the actual method that's nationally recognized on their scope of accreditation. It will say modified. So to answer the question, accreditation can accredit modified methods as long as it does prove that it's reliable through their validation process. Gordon, did you have anything else to add to that?
Yeah, just one more thing is that sometimes their clients require them to use a method that the client defines. So if the client is asking the lab to use that method, although it may not be in line with whatever accreditation methods are suggested, then they're providing a service to that client, so they would use the method that the client provides, but only under those conditions.
Okay. What specific records would you look for to determine analyst competence?
I'm going to go a limb here. The analyst is the one that's reviewing the test report. And based on that, is that this experience is number one in their position in the organization. Let's say, for example, the laboratory technical manager, and his responsibility is to sign off on all the test reports. So the test engineer, test personnel would conduct a test. They would sign it that they have conducted the test according to the policies and test methods that they have established in the lab. And the technical manager would sign off on those test results. So that specific record is their training, their experience, and their position within the lab. Would help determine the analyst's competence. And those records are part of the requirements in ISO 17025 that everyone that is in the approval chain has to have a training record, a personnel record of their training and competencies.
Okay, all right. One more question regarding the requirement for traceability of measurement. If a NIST traceable reference thermometer is used to verify annually the other working thermometers in the lab used for incubators, how frequent do we need to send out to external calibration provider the main NIST reference thermometer for calibration? Is it annually or every 3 years or every 5 years?
That would be usually identified by the NIST reference thermometer that say that has to be calibrated annually, biannually, and you would have to follow that that process. So, for example, I don't know this particular NIST reference thermometer. If NIST, who is the supplier of this reference thermometer, says that it has to be calibrated on an annual basis, then you have to have an annual recalibration, and you have to have a certificate with that reference thermometer that says the next calibration date. If it's 3 years, then you'd have to have it that the next calibration date is 3 years from the present calibration date.
Okay. Is a technical manager a quality manager also?
Normally it's not. The quality systems manager or quality systems manager is a different individual or person from a lab technical manager. But in small labs, that may be the same individual, but he does have 2 roles and responsibilities. And when he's exercising his responsibility as a quality manager, he has to ensure that his objectivity is stated with the quality management hat on. And then when let's say that same person is the technical manager for technical activities like reviewing of test reports, he has to ensure that the test reports meet the requirements of the client. It follows all the requirements of test procedures and test reports, and he signs off as a technical manager, not as a quality manager. So yes, it can be the same person.
Okay.
But you have to have those roles and responsibilities very clearly defined.
Okay, thank you. How do you document training when the tech is also the engineering designing the process?
Okay, I'm going to take this as they're developing the test procedures internally, and one of the individuals that is developing that test procedure is one of the technicians that is actually conducting the testing. So how do you document the training when that technician is also the engineer designing the process? Well, the engineer would have to say that he has training or competency based on what he has done in developing and designing the process. And that would be his qualification in very simple terms.
Okay, just some feedback on the one question we had about PT, proficiency testing for microscopic methods, is that there's difficulty finding another laboratory to compare results with that's local. So every accreditation body, and even our own policy, we have room for, alternatives. So our proficiency testing policy requires that the laboratory either choose a third-party proficiency testing provider, compares results through interlaboratory comparisons with associations or with other laboratories with the same accredited scope or same equipment technology. But if they can't, then there has to be an alternative. So laboratories could use 2 technicians within their laboratory, which is intra-laboratory, or repeatability studies may be used. So we accredit over 1,500 laboratories, all with unique different types of scopes. So we do run into this quite a bit. So in that case, you could develop your own internal plan. When you do that, though, you do have to seek, in our policy anyway, you have to seek our approval. So you have to put your proficiency tests, everyone has to create some type of 4-year plan and follow our frequency requirements. But when you use intralab or repeat studies, you do need to send in your procedure on how you're going to accomplish this and seek our approval before proceeding that to meet our accreditation requirements. So in this case, it's more doing something like that is better than nothing at all. So sometimes you do have to come up with your own proficiency testing criteria. And then also on our website, Gordon, I mentioned earlier, if you go to our resources under calculators or under proficiency testing, I believe there are some proficiency testing type of calculators that you can use to help set your PT up. So I recommend you looking at that.
Yes.
Okay, let me see if there's any more questions. Okay, I think we've answered all the questions for today. If there's anything else that you have questions about, please feel free to contact PGLA, and we'll get those questions out or responded to you as soon as possible. And again, this will be available, this recording will be available. I apologize for some of the glitches we had today with the internet, but I'm glad we got through everything. Okay, all right. Gordon, is there anything else that you would like to add? I think that we do have a little survey at the end. It's a two or three question survey, so please click on that for us. We'd like to continue to keep doing these webinars on an earlier time for those that are, not in the US that might be able to attend our earlier sessions. Gordon, anything else that you have to add?
No, I just appreciate everybody's patience with the vagaries of the internet. And I just would like some feedback from the folks that have participated, if this addressed their comments or concerns or the questions that they had, other than the questions that they posted on becoming more familiar with the requirements and the procedures of getting accredited.
Okay, all right, great. Well, thank you, everyone. We really appreciate your time today, and we look forward to doing more of these. Have a wonderful day. Thank you.
Bye-bye.
Bye. Bye. Thanks, Gordon.